You're able to see the screen?
Yes, sir.
Okay, all right. So, any doubts in previous class content? The fuse working, MCB working. So, MCB, you don't have to worry about the exact constructional details. You will have to just talk about the working of MCB. Okay, so you can start off the explanation by the bimetallic strip element. Okay, so during healthy condition, the material property remains intact, and only during abnormal conditions as in uh, could be fault in the load, or it could be fault in the external circuit. So whenever the current exceeds the rated value, the bimetallic strip the stretches, right? So by doing so, it is going to touch the solenoid contact, and the de-energization of solenoid takes place, and thereby opening the contactors. Okay, that's how it works. In modern times, we don't use uh, main fuse. Instead, we use a miniature circuit breaker, that is MCB, because fuse needs to be replaced as in when the fault occurs. On the other hand, MCB can be reused. That is the biggest advantage of MCB. Okay, fine. So that was regarding MCB, fuse, etc., etc. Okay. So today let us look at something known as electric shock phenomenon. Okay, so let me quickly open the syllabus. Yeah, so today we will be studying about talking about electric shock and precautions against electric shock, and then the concept of earthing. All right, so these are the three things we need to look at. Okay, electric shock, what is it basically? Electric shock, uh, it's a state in which a person or a human comes in contact with electricity. Okay, so when you come in contact with electricity, what happens is that uh, the current which was supposed to flow through the device or the appliance will take a bypass path through the human body. And based on the body resistance of the human, the person may receive mild shock or severe shock. Okay, so passage of electricity through human body is called as electric shock. And electric shock may cause due to intentional errors or unintentional errors. Intentional error in the sense, say for example, having known that the bare conductor is exposed to environment, and if you happen to touch it, it is utter negligence from the operator. Okay, unintentional error in the sense, let's say the appliance has developed some internal malfunction, so which is not visible to a human eye, and you know by mistake, if we happen to touch those appliances, then we may receive unintentional electric shock. Okay, so electric shock is nothing but state in which a person comes in contact with live electricity. All right. Now, what is the effect of this electric shock? So, electric shock can cause kind of biological effect on human body. When you say biological effect, what I meant to say is that it can cause a mild nervousness, or it can even cause severe tissue damage. So it can potentially harm a person. Now, the severity of electric shock depends on several factors. Factors such as the magnitude of electricity or the magnitude of current, the body resistance of the human body, and the time during which the person has come in contact with electricity. So these are the three major criteria that decides the severity of electric shock. Okay. Now, these electric shocks may be classified into two types: mild shocks and severe shocks. Mild shocks do not cause any harm to human body. Mild shocks basically cause something known as nervousness, touch me not sensation it gives, right? So whatever electric shocks we have experienced in our past, those were mild shocks, right? That's the reason we are alive. On the other hand, the severe shocks can cause severe amount of tissue damage. Okay, so basically what happens when the electricity flows through human body, right? Human body will have certain resistance. So when current flows through a resistance, the resistance starts to develop heat. The same thing happens to even human body. If the magnitude of current is very small, then it may not cause um, uh, good amount of heat within human body. So that can be classified as mild shock. So what happens during mild shock is that you get something like touch me not sensation. The moment you uh, come in contact with electricity or the bare conductor, the brain basically senses the disturbance in nervous system, and immediately it enables you to leave off the bare conductor. That is something known as touch me not sensation. Okay, that's possible only when um, the magnitude of current which is flowing through the device is very, very small. Okay, so brain will function very quickly during such a situation. On the other hand, during heavy shocks or when the magnitude of electricity that is getting flowing through our body is very, very high, then the heat generated due to the usage of electricity may be very, very high, due to which you can say that your blood starts to boil, and that's the reason you must have seen that you get second degree burns or third degree burns due to electricity. That's basically due to boiling of blood. Basically, the blood gets converted into steam, and you get those severe second degree burns or third degree burns. So those burns are very, very dangerous. It can potentially kill human lives. Okay, so that is the reason it makes sense to what do you say uh, understand the severity of electric shock, and also it makes sense to adopt a few kinds of precautions in our day-to-day life to protect ourselves from being electrocuted, right? Fine. So let us look at now the precautions to be taken against electric shock. Okay, so let me just open the file. Yeah, so yeah, that's all. I was talking about electric shock. Fine. Now, yeah, I was talking about magnitude and time at which current is passed through the body, and path of the current through the body. Okay, okay, you are able to see this word file, right? Yeah, I wanted to open this word file. That's the reason I took some delay. Fine. This is one of the very important aspect of electric shock, that is physical condition of the human body. Okay, physical condition of the human body in the sense the body may be completely dry, Okay, if the body is completely dry, the resistance can be as high as several kilos of ohms. On the other hand, if the body is completely wet, then the resistance of human body could be as low as a few hundreds of ohms. So you can gauge, the difference of human body resistance due to physical conditions. So that's the reason, normally it is advised not to touch electricity when there is water content in your hands or on human body. That's because when your body is completely wet, the contact resistance of human body decreases, right? So when resistance decreases, the magnitude of current that can flow through that resistance can increase. So that's the reason you have to operate electricity with dry hands, not with wet hands. Okay, fine. Now let us look at some of the safety precautions. Okay, so these safety precautions are, you have an exhaustive list, actually around 18 safety precautions I have listed down from standard literature. Okay, so apart from these safety precautions, you may have, the other safety precautions as well. Doesn't matter. Okay, let's look at the safety precautions. I'll just read out, so probably you'll be able to understand. Okay, so first of all, to protect human lives, you have to have something known as earthing in your house, right? So earthing, more of earthing will be dealt sometime later. Okay, so first thing is to have proper earthing at our houses. Okay, and then if at all any switches or any wires have broken, then that needs to be addressed immediately. So all broken switches, plug points, etc., needs to be replaced. Okay, and whenever you want to test whether the electricity present or not, then you are supposed to use a tester, which is also called as a line tester. Okay, so you must have seen tester. If you put tester in phase terminal, and if you touch the testing part of the equipment, then there will be a small blinking of lamp. So that indicates that at that particular moment the electricity exists. So always use a tester to check whether electricity is present or not. All right. And before replacing any of the faulty devices, you are supposed to turn off the appliances first. So first you turn off the appliance, then only you are supposed to carry out the repairing stuff. Okay. Then sometimes this is like the point number 6. Okay. Normally, they say jugaad kind of arrangement, right? So if you don't find a plug point, what do? You just use your mouth to open up the wires, and then you just start inserting those two phase neutral wires within the socket points. That is actually very dangerous. That's because while inserting, if the two wires, that is phase and neutral wire, accidentally, if they come in contact, then you are going to create a dead short circuit. So in an attempt to make a jugaad, you will end up in spoiling your entire wiring system. So it's okay if you don't have a plug point. It's better to go out and purchase a plug point. Okay, so you don't have to go for this temporary fixing solutions. You have to be very careful while doing so. Okay, and the 7th point talks about the attire, right? So the same point we have been discussing in class, that you are supposed to wear shoes while operating electricity or electrical apparatus, because the moment when you wear shoes, preferably with rubber soles, it increases the body resistance, right? You know that current is inversely proportional to resistance. So when you increase the body resistance, the current that may flow through the human body decreases. Okay, so that's the reason it makes sense to come to the electrical machines lab using a proper attire. All right. And yeah, when you want to repair any electrical appliances, it makes sense to use a dry wooden plank. Okay, so what you can do is you can stand on that wooden plank, and then you can operate or repair the faulty equipment. Okay, Fine. Point number 8, rubber gloves. We don't use it in our day-to-day life. That's because in our day-to-day life, we use single-phase electricity. So single-phase electricity is not so dangerous in the sense, I'm not talking about you can directly touch the electricity. No. If you wear a good rubber shoes, that's okay to carry out the repairing stuff. Okay. Now, the usage of rubber gloves comes into picture when you operate with high tension electricity, such as high voltage electricity. Anything which is above 400 volt may be regarded as high voltage. Okay. So whenever you deal with the repairing of three-phase appliances, it's better to go for rubber gloves. Okay. Then point number 9 talks about screwdrivers, cutting pliers with insulation, right? Of course, all the cutting pliers, screwdrivers, they do come with the insulation, either glass fiber, they'll use it as a material, fiberglass, sorry, fiberglass, they'll use it as a material, or good resin based material they will use. Okay. Yeah, the 10th point, that's what I was talking about. You're not supposed to touch two terminals at the same time. Okay. So two terminals as in phase and neutral terminal. So if you touch the phase and neutral terminal at a time, what happens is that you are going to provide a closed path across phase and neutral terminal. So electricity will flow through human body. So that's the reason you're not supposed to touch phase and neutral terminals um, at a time, because it creates a closed path, and current can flow only in the closed path. Okay. All right. So these are the major precautions, electric, safety precautions needs to be taken in order to protect ourselves from getting electrocuted. Okay. So I've discussed about 10. I have about, further 8 precautions that you can go through. Okay. Okay. See, it talks about usage of fire extinguisher, and yeah, switch off the electric appliances while carrying out any uh, repairing stuff, and never connect a machine or equipment to a voltage supply other than the rated one. Yeah, that's correct. For example, let us say we have a single phase appliance. So rating of single phase appliance is about 230 volt plus or minus 10%. So that buffer they will give. So either you can operate at 230 plus 10% of 230. Okay, that is 23 volts. Or you can slightly operate lower than 230 volts as well. On the other hand, if you happen to connect that 230 volt appliance to, let's say, some 300 volt supply, then it can cause permanent damage to the appliance. Okay, so that's the reason, what they are trying to say is that not to connect the equipment to a voltage which is not the rated voltage value. Okay. So these are the major precautions to be taken while handling electricity. All right. So that's about safety precautions. So in exam, you can expect about 5 to 6 marks question. So question could be something like, what do you mean by electric shock? And mention briefly the precautions to be taken against electric shock. So you can start with electric shock, and then you can explain about the different safety precautions to be taken. All right. So that's about um, this topic, electric shock and precautions. Okay. Yeah. So this is the. So this module is very simple because you deal with the general knowledge stuff. Okay. So you don't have to stress too much based on your reasoning. You can uh, explain the stuff. All right. Right. Finally, let's come to earthing. Okay, very, very important, especially for electrical engineers. Earthing. Yeah. Let me open the file. Okay. Now, what is earthing basically? We say earthing is done or earthing is not proper, etc., etc. Right? What do you mean by earthing basically?
Excess flow of current will be.
Yeah, flow of current through earth, right? That's what you were trying to say, right? Yeah, correct. So earthing is nothing but, it's a provision given for the flow of current to flow through the earth. Okay. Now, why earthing is required? Okay. Can you see this PDF file? This PDF file I have opened. You're able to see, right?
Yes, sir.
Yeah. Okay. Fine. So let me explain you the concept of earthing with the help of this figure. Okay. Yeah. Now, first of all, what I wanted to tell you is that you will not find earth pin in all the appliances. Okay, you can identify the appliance which is having the provision for earthing by looking at its plug socket. If the plug socket is having 3 pins, then you can say that that appliance belongs to earthing compliant category. Okay, in the sense, not all appliances will have 3 pins. Only few appliances will have 3 pins. Okay, you can name a few, right? For example, washing machine, water heaters, iron box, microwave oven. What else? Um, your toasters, yeah, and room heating machines, right? Air conditioning systems. You see, I have taken several examples, right? But in all these examples, one thing is common is that the power rating. All these appliances, they work on very high power level, right? For example, air conditioning. It works at 1800 watts, right? It consumes 1800 watts of power. Iron box, close to 1000 to 1500 watts. Water heaters, again, 1500 watts. Microwave oven is about 900 to 1200 watts. So when the power rating is quite high, you can say that the line current that the appliance may carry during its operation will also be a lot higher, right? So when you operate at this very high line current, it can uh, cause a kind of severe shock if you come in contact with those appliances. So that's the reason this earthing is provided only to few appliances which are carrying a very high current. All right, fine. So that's about the earthing provision for appliances. Okay. Now consider a case in which, let's say, you have a machine. Okay, so this machine is being depicted with the help of an inductor, because all electric machines are kind of inductive in nature, right? Now, imagine that the machine is not earthed. Okay. So, yeah, first of all, I need to tell you what is earthing. So, earthing is a process in which the metal part of the body is connected to